So today we are going to discuss UG NEET 2021 question paper discussion. Now we are going to discuss the N3 paper. So in N3 paper section A, start from 51 to 85. So nearly 35 questions are there. So you have to attend all the 35 questions in this section A. The first question, that is 51 question in chemistry. The first is right option for the number of tetrahedral and octahedral voids in hexagonal primitive unit cell. So this question is from solid state. From grade 12. Okay, so you all know the total number of cells present in hexagonal primitive cell is 6. Okay, n is equal to 6. For octahedral void, that is equal to n. Here you know the n value, n is equal to 6. So tetrahedral void is equal to 2 into n, 2n. So 2 you write the numerical part and substitute the n value 6. So your answer is 12. So here question is first tetrahedral. So in this choice 6 and 12 is given. First this is tetrahedral. So you choose 12. So this option is correct, I think. 12 into 6. So this 12 is for tetrahedral void and 6 is for octahedral void. Okay. So this is the correct answer. So right option for the number of tetrahedral and octahedral voids in hexagonal primitive unit cell are 12 and 6. So this is the total number of cells in hexagonal primitive cell is n is equal to 6. I already explained. So the n is equal to 6. The number of octahedral void is also equal to 1 n. So n is equal to 6. The number of tetrahedral void is equal to 2 into n. So 2 into 6 is equal to 12. Okay. So the total number of tetrahedral void is equal to 12 and total number of tetrahedral void is 12 and octahedral is 6. And then 52nd question, BF3. So this is boron trifluoride. So in our regular class itself, so many times I already told. So this boron trifluoride is the electron deficient compound. So in 2013-15 question also, we already get one question from this part, boron trifluoride part. So this time, so this is little bit different, but this question is from grade 11. In P block elements, you study the P block elements in both grade 11 and grade 12. So this is from grade 11 portion, that is 13th group of P block elements, 13th group of P block elements. Okay, here the clue is electron deficient. Okay, so you choose these two things. So this 8 is not. So 8 means octet structure, that is not electron deficient. So this option is absolutely wrong. Hybridization is sp2. Other two options are sp3. So these two options also wrong. Okay, so the hybridization in BF3 is sp2 and the number of electrons around the central atom is 6. Okay, so the valence electron in, so the correct option is this one, second one. So this is the boron electronic configuration. So these 3 electrons are considered as valence electron, valence shell electron. So these 3 valence shell electron is combined with 3 fluoride electrons. So 3 plus 3 is equal to 6. Okay, so the total number of electrons present in the central atom is equal to 6. See this one. Okay, so here this is the 3 electrons in boron and this is 3 electrons in fluoride. So 3 plus 3, 6. So sp2 6 is the correct answer. This is boron trifluoride. So this 3 electrons, 3 pairs of electrons are involved in covalent bond formation. Covalent bond formation. And the next question, 53rd. Which one of the following methods can be used to obtain highly pure metal which is liquid at room temperature? So, the one liquid metal is mercury. Okay, I think the correct option is distillation. So, what is distillation? So, distillation is a process involving the conversion of a liquid to vapor. So, 3 phases are present, that is solid to liquid and then liquid to gas. Okay, so this liquid to gas or vapor, so this phase is called as distillation and subsequently condense again gaseous state to liquid state. So, this is distillation. And again this is condensation. So, this is involved in purification and isolation of metals. So, this question is from metallurgy. Okay, I think this is also you studied in grade 11 portion. So, as well as you study the same concept in organic chemistry, GOC also, GOC in organic chemistry. So, that is also in grade 11. So, this is the interrelated question. And then 54th question, for a reaction A to B. So, this is reactant. So, the reactant A is converted into reactant B. The enthalpy of reaction is given, that is minus 4.2 kilojoule per mole. And the enthalpy of activation is 9.6 kilojoule per mole. So, the correct potential energy profile for the reaction is shown in option. So, in this enthalpy we studied both potential energy and as well as the kinetic energy. But here the question is from the potential energy. So, from the information given in the question, it is very clear that this is exothermic reaction. So, what is exothermic reaction? The heat is liberated during chemical reaction. Heat is liberated during chemical reaction. Okay. So, I think the question is the A option is correct. So, this is potential energy you take in y axis and then reaction progress is in x axis. Okay. So, the reactant A, the potential energy of the reactant A is in higher compared to that of the potential energy in B. So, this is the activation energy peak. So, the potential energy gradually increased and then after the peak, so it will goes down and then comes to B, that is in product side B, the potential energy is compared to A reactant, the potential energy is less. I think this one is the correct answer because this reaction is the exothermic reaction. So, okay, so the reaction is exothermic. And then 55, question number, noble gases, though this is also again from the P block element. The group is 18th group. You studied this one in grade 12. Okay, so noble gases are otherwise called as inert gas because this one is chemically inert. So, totally 7 elements are present in this group. So, all are having octet structure except helium. Okay, so all are chemically inert or less reactive, so that only all gases in this category is considered as inert gas. named. Why these gases are considered as inert gas or noble gases? Because of their inertness towards chemical reactivity. Okay, already they are satisfied or well stabled by having the octet structure in its outer shell. Identify an incorrect statement. So here 4 statements are given. So you have to pick the incorrect statement. The first one, noble gases have very high melting and boiling point. I think the first point itself is the incorrect answer. That is answer for this one. The noble gases, the name itself, the phase or states of matter of these 7 elements are considered as gaseous one. So in gaseous state we already discussed the gases have very low melting point and boiling point. In atomic state itself, so these 7 elements are present in gaseous form, that is helium, neon, so they do not form a molecule. Okay, argon, like this up to oganesson. I think this one is correct. Answer for this one, but this is incorrect, not relevant to the noble gases. All other 3 options, noble gases have weak dispersion forces, noble gases have large positive values of electron gain enthalpy, noble gases are sparingly soluble in water. These 3 things are correct statement for noble gases, correct statements. And the next question, 56th question. The structures of beryllium chloride in solid state and vapor phase. So the beryllium chloride structure is different in solid state and as well as in vapor phase. So you have to pick, but these 2 options are absolutely wrong because in both the phases the shapes are different, but here linear in both and chain in both. So you have to choose whether option from these 2 things, dimer and linear or chain and dimer. So beryllium chloride first solid, in solid that is in chain form, and in vapor phase it exists in dimeric form. Okay, I think the 4th option is the correct one. Yes, so this is from S block elements. Particularly 2. So this beryllium belongs to alkaline earth metals. Another one question is also from the same beryllium chloride, we will discuss later, alkaline earth metals. Okay, so I will show the diagram. So this is solid state. So this is in chain. So this beryllium you have to, the chain increased like this. But in vapor state, so this is complete. So this is in dimeric form. So this is one BeCl. This is again one BeCl. So this is in dimeric form and this is in chain form. So the correct option for this one is chain and dimer. Chain in solid state and dimer in vapor phase. And then 57th question. Acid strength increases in the order given as here: hydrogen fluoride, hydrogen chloride, hydrogen bromide and hydrogen iodide. So this also from, okay, so this is redox, and then we studied the same concept in chemical equilibrium. And then from P block, halogens, that is 17th group. Okay, so here this is reason and assertion type of question, reason and assertion type of question. I think so this paper 2021 paper contains, I think, 3 reason and assertion type of questions. So the first question, acid strength increases in the order. So the acid strength is more in hydrogen iodide compared to that of the hydrogen bromide, hydrogen chloride and hydrogen fluoride. I think this one is correct because so the size increases down the group. So automatically the acid strength also increases. Okay. Second statement, as the size of the element fluorine, chlorine, bromine, iodine increases down the group. So this is down the group. So here increases size. Okay, so the bond strength also increases. If bond strength increases, automatically acid strength also increases. So here 4 statements are given. Both statement 1 and statement 2 are false. I think this one is wrong. Statement 1 is correct, but statement 2 is false. So this is also wrong. Statement 1 is incorrect, statement 2 is true. So this is also wrong. I think both the statements, statement 1 and statement 2, the reason and as well as the assertions are correct. Okay, so this one. And then 58th question. So this question is from polymer chapter, organic chemistry, and then grade 12. Okay, so which one of the following polymers is prepared by addition polymerization? Okay, so 2 different types of polymers are possible to form. One is addition polymer, and second one is condensation polymer. So the process involved in the synthesis of addition polymer is called as addition polymerization. Addition polymerization. And then condensation polymer, the method involved here is condensation polymerization or copolymerization. So here your question is, which one of the following polymer is considered as the addition polymer? Okay, so addition polymerization, these 3 things are considered as condensation polymer, and this one is addition polymer. So what's the condition for addition polymer? Means the monomer must contain, at least one double bond. Here the answer is Deflon is correct. So this is the addition polymer. So this is the structure CF2 N times. So you write the monomer. Okay, so this is C double bond C. So this is the derived product of the ethene. So this is ethene. So all 4 hydrogens are replaced by fluorine. So it has one double bond. So this is the condition for the addition polymer formation. Okay, so your structure is C double bond C, F, 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 F. So this is tetrafluoro. Fluorine is in 4 times, so tetrafluoro. So the parent hydrocarbon is ethylene, so ethene, tetrafluoroethene. So this polymer is used to manufacture so many non-stick cookware. Fifty-ninth question. A particular station of All India Radio New Delhi broadcast on a frequency of 1368 kilohertz. So this is for frequency for radio wave. So this one is called as radio wave. So, the wavelength of the electromagnetic radiation emitted by the transmitter. So, wavelength, that is lambda. Okay. So, you have to apply these things in the C value is given, and then here mu value is also given. So, from these values you have to easily calculate the wavelength of the electromagnetic radiation. So, the correct answer is 219.3 meter. So, this is the formula. Lambda is equal to C by mu. You know the C value, you know the mu value. You have to substitute the things. 3 into 10 to the power of 8 divided by 1368 into 10 to the power of 3. Okay, first you have to take this scientific notation from denominator part to numerator part, 10 to the power of 8. So, it will goes in negative sign minus 3. So, 3 into 10 to the power of 5 divided by 1368. Okay, so finally you have to cancel, you get the answer 219.3 meter. So, the fourth option is having the exact value 219.3 meter. Okay, since the frequency of radiation is 1368, I already explained. So, this is called as radio wave. And 60th question, that is zirconium and hafnium. Okay, so these two elements, atomic number is also given. This is Z equal to 40 and Z equal to 72. So, this is atomic number. Have similar atomic and as well as the ionic radii. Okay, so what's the reason behind this one? So, this is from grade 12 chapter. D and F block elements, D and F block elements. Okay, here 4 reasons are given. Diagonal relationship, that is you study in S and P block only, not in D and F block elements. So, this is also wrong. And then having similar chemical properties, even though they belong to the same group, having similar chemical properties and as well as the periodical properties, and this is also not relevant to this question. Okay, because and then belonging to the same group. Okay, but the correct explanation is lanthanoid contraction is the correct one. So, due to the contraction, that is the lanthanoid contraction is due to the poor shielding effect of the 4d and 5d electrons. Okay. And then this is lanthanoid contraction. So, how many elements are present in lanthanoids? 15 elements are present in this group. So, the size decreased like this, contraction is due to this one. Okay. So, usually we express the radius value in picometer. And then 61st question, this is list match the following type of question. I think this paper also having 4 such type of question, match the following question in both section A and as well as the section B. Here some molecules are given, PCl5, SF6 and BRF5 and BF3. You have to match the exact geometry, molecular geometry. Okay, so PCl5, I think. So, this is trigonal pi pyramidal. I will show the diagram also. And then second one, SF6. SF6 is the octahedral. So, this one is octahedral. And then BRF5. So, that one is square pyramidal. And then BF3 trigonal planar. We already discussed this BF3 in the second question itself, that is electron deficient one, everything. I think this is the correct answer. Yes. So, A is 4 and B is 3 and C is 1 and D is equal to 2. So, we also match like this. So, this is the structure, trigonal bipyramidal. So, this is PCl5 and then this one is SF6, and then square pyramidal BRF5, and then this one is BF3. So choose the correct answer. I think the option 4 is the correct one. And then 62nd question, what is the IUPAC name of the organic compound formed in the following chemical reaction? So 2 questions of this paper, 2 questions are from this IUPAC name. So this is also in grade 11 paper. So in GOC, General Organic Chemistry. Okay, so acetone. So it is the best example for ketone. Ketone reacts with this one is Grignard reagent in the presence of dry ether and water. So you get one product. So the product is in this secondary alcohol. Okay, so this is the product must be alcohol, particularly secondary alcohol. So here 4 options are given: pentan 2-ol, pentan 3-ol, and 2-methyl-butane 2-ol, 2-methyl-propan 2-ol. I think so this 2-methyl-butane 2-ol, because the acetone itself 3 carbon atom is present, that is CH3, C double bond O, CH3. Okay, so 3 carbon atoms are present here, and then in Grignard reagent itself 2 carbon. So 2-methyl-butanol. So this is 5 carbon compound. I think so this is in second position. Methyl-propanol means 4 carbon atom. I think this option is absolutely wrong. And this pentan 2-ol again 5 carbon atom, and this one is 5 carbon atom. Okay, I think these 2 things are primary alcohol. But your condition is the acetone reacts with Grignard reagent to get secondary alcohol. I think so the third option is the correct one. Okay, so this is secondary. I will show the diagram. So this is CH3, C, CH2, CH2, CH3. Okay, and then OH. Okay, so this is first, second, third, and then fourth one. Okay, so in the second position, so methyl group is also present, and then hydroxyl group is also present. So 2-methyl-butane 2-ol is the correct one. Sixty-third question, again this question is also from organic chemistry paper, and this is also from GOC grade 11. Okay, very simple question. So an organic compound contains 78% by weight of carbon and remaining percentage of hydrogen. So you calculate the remaining percentage. So this is 100, percentage means 100. So 100 minus 78 to 22%. Okay, so this is hydrogen, 22% hydrogen. Okay, so here you need to calculate the empirical formula only, not for molecular formula. Okay, so from the empirical formula, you can easily calculate the molecular formula. You find the N, you have to multiply that N value with this empirical formula, you get the molecular formula. But here your question is very simple, you need to calculate the empirical formula alone. Okay, so CH2, CH3, CH4, CH is given. So this is methylene group, and this is methyl group, and this is methane, and then this one is carbon and hydrogen. I think this CH3 group is correct. Okay, how to calculate this one? So this 78% of carbon, and this is atomic mass of carbon. You have to divide, you get the value 6.5. And this is 22, this is atomic mass of hydrogen, 22 divided by 1. So you get 22 and 6.5. Which one is lesser number here? So 22 or 6.5 is the less value. So 6.5 divided by 6.5, you have to cancel 1. So the carbon is in 1 and then hydrogen 22.6.5, 3.38. So this 3 is less than 5. So you omit these things, you get 3. So CH3. Okay, so that only I choose the answer CH3. And then 64th question. So this question is from chemical equilibrium directly. So this is grade 11 portion. So this time 50% mark from grade 11 and 50% mark from grade 12. And then the section A compulsory questions are from, most of the questions are from grade 11. Okay. So the BKB dimethylamine and pKa acetic acid. So this is base and this is acid. So these two things combine together to get dimethyl ammonium acetate. So one acid and bases combine together, neutralization reaction occur. So the product is nearly the pH of 7. Okay, here. So this 7.75 is near to the pH 7. Okay, so 7. And then next one is 8. So 7. So this pH is in between these two things. So that is almost neutral. Or you call it a slightly basic. So this one is slightly basic. Okay, acetic acid are 3.27 and 4.77 respectively at T Kelvin. So the correct option, the pH of dimethyl ammonium acetate. So you have to pick the answer laterally or you have to calculate the exact value. So this is the formula. pH is equal to 7. So this is neutral pH plus 1 by 2 into pKa value minus pKb value. Here pKa value is given in the question, pKb value is also given. So you have to find the difference. So 3.27 minus 4.77. You have to minus the things. Okay, so 4.77, 3.27, 0.5 and 1.50. Okay, so 7. Okay, plus 1.52 divided by 2. So you get 7 2s are 14, remainder 1, 0. So 5, 0.75. So you have to add the things, 0.75, you get the answer 7.75. And then the right option for the statement, Dintal effect. So you study this one in surface chemistry, in colloid chapter, surface chemistry. So in chapter colloids, and this is from grade 12. So the right option for the statement Dintal effect is exhibited by glucose solution, starch solution, urea solution and NaCl solution. So the starch solution is, so that is starch is sparingly soluble in water. Starch is sparingly soluble in water. Okay, and then so you get the colloidal solution. All other things are easily soluble in water to get the pure true solution. Okay, so you get a true solution. So this Dintal effect is more specific for colloids. So out of 4 solutions given here, 1 solution is considered as colloid. So automatically you have to choose that option is the correct option, colloid, starch solution. So I think, so the second one is correct. So this is Dintal effect. So this is for true solution and this is for colloidal solution, true solution. So the scattering of light is due to the presence of this colloid, okay. So this is start solution. So this is example for glucose, urea, and then salt solution. And then tritium. So tritium is the radioactive element, and this is radioactive isotope of hydrogen, emits which of the following particles, okay. So I think the beta particles, high energy electrons. So this is nothing but high energy electrons. So the beta particles are the correct answer. A beta particle is a high energy particle with a high speed electron or positron emitted in the process of beta decay. So it's denoted by the symbol beta. So are emitted during the radioactive decay of an unstable atomic nucleus. Here the unstable atomic nucleus is tritium. And then the correct sequence of bond enthalpy of C into X. Here X is halogen. I think this question is from grade 12 portion. Haloalkanes. Okay, so this is alkane group and this is F, that is halogen group. So that is fluorine, chlorine, bromine, iodine. Okay, so I think so the first option is correct. So we already discussed this fluorine, chlorine, bromine, iodine. Okay, so if atomic size increases down the group, so automatically this bond enthalpy is also increased. Okay, so the bond enthalpy is increased for the small size element present in this group. So here the small size element present in this group is F. Okay, so this is inversely proportional. So if size reduced, so automatically the bond enthalpy is increased. So this one is correct. So shorter the bond, stronger will be the bond, higher will be the bond enthalpy. If this bond is more stronger, so you have to give more amount of energy to break that bond. So the bond enthalpy is high in the haloalkane of having the small sized halogen group. Okay. Then 68th question. The following solutions were prepared by dissolving 10 gram of glucose in 250 ml of water. So the glucose is hexo sugar, 6 carbon sugar, and this is monosaccharide. So there is no glycosidic bond is present. And then second one, urea. In urea, in addition to the carbon, hydrogen and oxygen, another one hetero element is also present, that is nitrogen. And then sucrose. So sucrose is this is also carbohydrate but disaccharide. So here the glycosidic linkage is present in this case. So your question is the right option for the decreasing order of osmotic pressure of this solution. This question is from solutions chapter. So in solution chapter comes under colligative properties. So we already discussed 4 different types of colligative properties in the class. Okay, and this is from osmotic pressure. Okay, so how to calculate this osmotic pressure? So this is how much gram, that is 10 gram, 10 gram, and then this is 10 gram. So you have to divide it by N. Okay, so these are, I'll explain the solution. So P1, P2, P3, and then P2, that is osmotic pressure for urea is great. I think these two things are wrong because the nitrogen containing group, this one is having the more osmotic pressure. So you choose these 2 options. I think the 4th option is the correct one. Okay, and then the osmotic pressure, moles of glucose is equal to 10 divided by 180. So this is atomic mass for glucose. So you have to sum up the atomic mass of carbon, hydrogen and as well as oxygen, you get 180. You have to cancel 0, 0. So your answer will be 1 by 18. And then this is you have to cancel 1 by 6. And this is 10 divided by 342. So this is very less. Okay, so which one is greater? The second one. So this is P2 and this is P1 and this is P3. So here 1 by 6 is greater than that of the 1 by 18 is greater than that of the 10 by 342. So this is for P2 and this is for P1 and this is for P3. So compared to P3, so the osmotic pressure for glucose and as well as the urea is higher. Okay, so this option is correct one. And 69th question, identify the compound that will react with Hinsberg's reagent to give a solid which dissolves in alkali. I think this Hinsberg's reagent is used to distinguish the primary alkene from the secondary and tertiary one. I think these three are come under this amines part, and this one is an irrelevant option here. So you have to delete this one, omit this one. So you have to choose the option from these three things. Okay, and this is primary amine and this is secondary amine and this is tertiary amine. Okay, here two hydrogens are present, here only one hydrogen, here there is no hydrogen is present here. I think this Hinsberg's reagent is more specific for this primary amine. I think that option is correct. Okay, the Hinsberg's reagent. So what's the use of this Hinsberg's reagent? So this is used to detect or distinct between primary, secondary and tertiary amine. So Hinsberg's reagent is otherwise called as benzene sulfonyl chloride, that is C6H5SO2Cl. So along with carbon and hydrogen, oxygen, sulfur, these belongs to the same family, and this is from another group of this P block element. So all these three P block elements combined together with the hydrocarbon, you get benzene sulfonyl chloride. So this benzene sulfonyl chloride is the chemical name for Hinsberg's reagent. And then 70th question. So the compound which shows metamerism. Metamerism is also one type of isomerism. Okay, so having different R group attached to the functional group. I think here C4H10O is the correct answer. So from this you have to form two or more ethers by using the same molecular formula. So C4H10, so you write C2H5O, C2H5. So this is also the molecular formula C4H10O. So this is diethyl ether or ethoxyethane. Okay, so this is diethyl ether. And the next one CH3O, C3H7. Here also C3. Okay, and then here one C4 and then H10O. So here both the R groups. So this is R and this is R prime. And this is R and this is R prime. So here the R and R prime groups are different. So both are having the same molecular formula but different structural arrangement like this. So such type of isomers are called as metamerism. So this one is correct. Okay. So I have given these two structures. So another one structure is also given, methoxypropane. Okay, so metamers, what is metamers? Metamers are the isomers having the same molecular formula but different alkyl groups on two sides of the functional group. So here the ether is the functional group. Okay, this is symmetrical ether. So both R and R groups are common. So this is symmetrical. And these two things, that is asymmetrical. And 71st question, we already discussed one reason and assertion type of question. So this is the second. Statement 1, aspirin and paracetamol belong to the class of narcotic analgesics. So these two things comes under analgesics but not narcotics. So this is false. And second statement, morphine and heroin are non-narcotic. I think this is wrong. This is narcotic. So this is also considered as analgesics. Okay. And then in the light of the above statements, I think both these statements are false. So this question is from grade 12. Chemistry in everyday life. Chemistry in everyday life. So particularly chemicals used in medicine field. Chemicals used in medicine field. And then choose the correct answer from the options given below. We already discussed, no, I think. So both statement 1 and statement 2 are false. Reason and assertions are false here. I think this is the correct answer. Yes, this one is correct. And then 72nd question, choose the correct option for graphical representation of Boyle's law. In gaseous state, we have discussed so many laws, Boyle's law, Charles' law, and then Avogadro's law, Gay-Lussac's laws and everything. But this question is from Boyle's law, which shows a graph pressure and volume, pressure versus volume, pressure you take in y-axis and volume in x-axis. Of a gas at a different temperature, you have to vary the temperature. So you have to notice the pressure and volume changes. So the first diagram is only the straight line, the 200 Kelvin, 400 Kelvin and 600 Kelvin. I think this is wrong because this is inversely proportional. And this is also wrong, 200, 400 and 600. And third one, so this is inversely proportional, no. So the Boyle's law is inversely proportional. I think the third option is correct one, inversely proportional. And then Boyle's law is a gas law which states that the pressure exerted by a gas of a given mass kept at a constant temperature is inversely proportional. So this is more important, inversely proportional to the volume occupied by it. So this is gradually decreased 600 Kelvin, 400 Kelvin and 200 Kelvin. And the correct structure, again this is also second question from IUPAC. So this is also from GOC chapter, that is grade 11. So in the previous one reaction is given. So you have to write the product, the IUPAC name of the product. But here the structure is given. So you have to pick the correct name, pick the correct structure for the given name. Here the clue, in second position and sixth position methyl group is attached. And in the fourth position, one double bond is present. So the deck means 10 carbon atoms are present. Okay. So here 2 methyl, in all 4 structures 2 methyl groups are present. Okay. So you don't omit anything. And then deck. So all are having 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. So the next one, fourth one. I think so you start from this one, 1, 2, 3, 4. Okay, and then here also 1, 2, 3, 4 and all these things 1, 2, 3, 4. So based on this ene, so you omit this structure. Okay, and then 2, 6 dimethyl dec 4 ene. So this is consider this one means 1, 2, 3, 4, 5, 6, 7, 8, 9, 6, 9. But here in second and sixth position only 2 methyl groups are present. So you have to omit this one also. Now You select the correct answer from these two things, okay. So, consider this one, 1, 2, 3, 4. So, this is 3. In third position itself, the double bond is formed. So, this is also wrong. So, you have to choose, I think this is the correct one, 1, 2, 3, 4. In fourth position, double bond is formed. 1, 2. In second position, one methyl group is present. And 1, 2, 3, 4, 5, 6. In sixth position also another one methyl group is present. I think so. This is absolutely correct one. Okay. And this is 1, 2, 3. In second position one methyl group is present. And in sixth position another one methyl group is present. And then in between fourth and fifth carbon atom one double bond is present. The total number of carbon atom present here is 10. So, you write the name for this structure is 2,6-dimethyl-tech-fluorine is the correct answer. And 74th question. So, the incorrect statement among the following is, most of the trivalent lanthanoid ions are colorless. I think this is absolutely wrong. This is incorrect. Because, so the lanthanoids and actinoids come under F block elements. So, the D and F block elements are colored substances, so that only so many coordination complex are formed. So, these ions act as the central metal ion or atom. And then other things. So, obviously the lanthanoids and actinoids are solids. So, they are the good conductors. Actinoids are highly reactive metal, especially when finely divided. So, that only the actinoids are used as the catalyst. In the finely divided actinoids elements are considered as the catalyst. And then actinoid contraction, similar to that of the lanthanoid contraction we already discussed, is greater for element to element than lanthanoid contraction. Okay, I think this one is wrong statement or incorrect statement. So, this is due to the +3 oxidation state of the lanthanoids. Okay, so the lanthanoid ions with +3 oxidation state are colored both in solid state and in aqueous solution. Okay, so the color of cation depends on the, so cation, so that is positively charged. So this one is positively charged. So, depends on the number of unpaired F electrons, lanthanoids with X into F electrons have the same color as 14 X electron elements. And then 75th question, which of the following reactions is the metal displacement reaction? So, this is very basic question. You studied this double displacement or single displacement in your grade 10 chemistry itself. Okay, and this question is from Redox reaction. Types of Redox reaction. So, in this reaction itself, two different metals are present. So, in reactant type, chromium is present. So, this is metal. And in product side, aluminium. So, this is, so this Cr2 is replaced by this aluminium, because compared to chromium, aluminium is more reactive. Okay, so chromium oxide plus aluminium is heated. So, you get alumina. So, the chromium oxide is readily converted into aluminium. So, this chromium metal is displaced by this aluminium metal. But other cases, in both the reactant part and as well as the product part. So, only one metal is involved in these reactions. Here iron. Okay, so here the only metal involved in the reaction is iron, and this is lead, and this is potassium. Okay, so obviously the first one is the correct answer. And then 76th question, which one among the following is the correct option for right relationship between CpCv for 1 mole of ideal gas? Okay, so Cp minus Cv is equal to R. So, this is the formula. This is a very direct question. So, this one is the correct option. And then 77, I already told no. So, the beryllium chloride. So, we already discussed in solid phase and in vapor phase the molecular geometry of the beryllium chloride. Again, another one question is from the S block element 2. Okay, so among the following alkaline earth metal halides, one which is covalent and soluble in organic solvents. So if the compound is ionic compound, means that is readily soluble in water, but this compound is covalent, not soluble in water, so that only it's soluble in organic solvents like ether, alcohol, acetone, whatever it may be. Okay, so the first, mostly the alkali metals and alkaline earth metals form ionic compounds only, except lithium in alkali metal. Okay, and then second one, so the beryllium in the alkaline earth metals. Except these two things, other alkali metals and alkaline earth metals are considered as covalent compounds. It can form covalent. So not dissolve in water, soluble in water, I think. So this beryllium chloride is the correct one. So you write the order. Okay, so beryllium, this is the first element, second element magnesium, and then calcium, and then strontium. So the atomic size increases down the group. And then this is beryllium chloride. So this is covalent bond formation, that is sharing of electrons occur here, sharing of. So instead of forming, that is transfer of electron, here sharing of electrons occur during the bond formation. So the covalent bond is formed. So the covalent compounds not soluble in water, not soluble in water. That is soluble in organic solvents. So you choose any organic solvents, okay. And then 78th question. So dihedral angle of least stable conformer of ethane. So two different conformer is possible to form in ethane. One is highly stable conformer and another one is least stable conformer. So I think the least stable conformer having the angle 0 degree. Okay, and then the most stable one is forming this one, that is 60 degree. So this is least stable. I will show the two conformation also. Okay, so least stable. So this one is correct. Okay, and this is staggered conformation. So this staggered conformation is most stable conformation, most stable. So here the angle is 60 degree, 60 degree, 60 degree, 180 degree. And this one is ellipsed, one is least stable. That is 0 degree. Okay. And then 79th question, ethylene diamine tetraacetate. Okay, so this is again ligand. So this is from coordination compound. Coordination compounds from grade 12. Okay, so here this one is a ligand. So you have to choose the type of ligand, EDTA. And then what is ligand? So it can easily donate a pair of electron, means that is considered as a ligand. In EDTA, two different elements are involved in the donation of the electron. One is oxygen and another one is nitrogen. Okay, so here 6 pairs of electrons are donated. Okay, so the ethylene diamine tetraacetate can donate how many pairs of electrons? So 6 pairs of electron. Out of 6 pairs, 4 pairs from oxygen and 2 pairs from nitrogen. Okay, I think this is hexadentate. Hexa means 6 hexadentate ligon with 4 oxygen and 2 nitrogen donor atoms. I think this one is correct. I'll show the diagram. So this is okay. So here this nitrogen can donate to 2 pairs and then oxygen. So this one and this one, this one and this one, 4 pairs. So 4 plus 2 pairs and then 6 pairs of electrons. That ligand donates 6 pairs of electrons. And then the RBC deficiency is deficiency disease of. So all are come under, that is vitamin B complex. Vitamin B complex. But only one is responsible. Okay, so the deficiency disorder for RBC deficiency. Okay, so RBC deficiency means anemia. So that is depletion in or reduced in number of RBC, depletion in red blood cells. Okay, vitamin B6, vitamin B1, vitamin B2 and vitamin B12. I think this vitamin B12 is responsible for the deficiency disorder of this RBC. This vitamin B12 is nothing but pernicious anemia. Okay, good. That one is. So, the most common cause of vitamin B12 deficiency is anemia. So, the special name for that disease is pernicious anemia. So, lack of a substance called intrinsic factor, which can be caused when your immune system mistakenly attacks the stomach cell that produce these substances. So, this type of anemia is called as pernicious anemia. And then 81 question. So, the maximum temperature that can be achieved in blast furnace. So, the blast furnace is used in the extraction of the iron. Okay, so extraction of iron. So, the extraction of iron needs more temperature because iron is a very strong metal having high melting and boiling point. So, it needs more temperature. Okay. So, here the question is the maximum temperature. So, here the options are given 2200, 1900, 5000 and 1200. I think this up to 2200 Kelvin is the correct answer. Okay. So, the purpose of a blast furnace is to chemically reduce and physically convert iron oxide. So, 2 different iron oxides are present, that is ferrous oxide and another one oxide is ferric oxide. Okay. So, into liquid iron called hot metal. The blast furnace is a huge steel stack lined with refractory brick where iron ore, coke and limestone are dumped into the top and preheated air is blown into the bottom. So, at 2200 degrees Celsius, so the iron oxides gets melt and convert into the hot metal. So, this is the furnace setup. Okay, so the maximum temperature for this blast furnace is 2200 Kelvin. Okay, so almost to see this one is 2170 approximately equal to 2200 Kelvin. Then 82nd question, the major product of the following chemical reaction. So this is bromination reaction, bromination. So, this question is from hydrocarbons, particularly alkenes. So, in alkenes, so this comes under addition reaction. So, it comes under addition reaction. So, in addition reaction, we discussed two different types of the mechanism. One is Markovnikov's rule and another one is anti-Markovnikov's rule. I think this reaction is for anti-Markovnikov's rule. This is the best example for anti-Markovnikov's rule. So, the hydrogen is attached to the carbon having less number of hydrogen and bromine is attached to this one. Actually, this is the just opposite to that of the Markovnikov's rule. Okay. So, I think, so the answer is this one. Yes. So, the hydrogen is attached to this one. So, the double bond is removed. So, the bromine is attached to this one. And then addition of hydrogen bromide in presence of peroxide follows anti-Markovnikov's rule. And then 83rd question. So, the major product formed in dehydrohalogenation reaction of 2-bromopentane. Again, this is also from both. This is the interlinked question in haloalkane and as well as the alkene. So, the product formation is based on, so Hund's rule. So, this is not relevant to this one. Hund's rule is used to fill the electrons in atoms, okay, so in orbits. And then Hoffman rule, Huckel's rule and Saitse's rules. I think Saitse's rule is the correct one. So, in 2020 paper also one question is from this same rule. Okay, I think this Saitse's rule is the correct one. Okay, so according to Saitse's rule, in dehydrohalogenation reaction, so the preferred product is that alkene, which has greater number of alkyl groups attached to the doubly bonded carbon atom. For example, the dehydrohalogenation of 2-bromobutane yields two products. One is 1-butene and another one is 2-butene. And 84th question. So, the molar conductance of NaCl, HCl and CH3COONa, and this is sodium chloride salt, hydrogen chloride acid and CH3COONa, again salt of acetic acid at infinite dilution. So, the dilutions are given. So, this is for NaCl and this is for HCl and this is for CH3COONa. So, the molar conductance of CH3COOH in infinite dilution is, I think this is in electrochemistry chapter. So, you already studied in this one in physics also, okay, electrochemistry grade 12. And 390.71 S centimeter square per mole, 698.28, 540.48, 201.28. I think so. This three, yes, this one is correct one. How to calculate this one? So, this is okay. So, the calculations are given below. So, this is molar conductivity of this acetic acid and then sodium acetate plus HCl minus NaCl. So, you know all the values, the molar conductivity value of this NaCl is given, sodium acetate is given and HCl is also given. So, you have to substitute all the things and then you have to sum up these two things and then after the addition or summation of these two things, you have to find the difference. Okay, so, this is 426.16 and 91.00. So, 517.16. So, this is 126.45. So, this is 1 and this is 11 minus 4, that is 7, 6 minus 6, that is equal to 0. And this is 11 minus 2, 9. Okay, and then already 4 minus 1 is equal to 3. So, 390.71 cm square per mole is the correct one. Okay, so that is I choose this option, first option. And then 85th question. So, this is the last question of section A. And then after that we will discuss the section B. Okay, so the correct option for the number of body-centered unit cell in all 14 types of Bravais lattice unit cell is 5237. I think this 3 is the correct answer. So cubic, tetragonal and orthorhombic have BCC unit cells. Okay. And section B. So here 15 questions are there. So out of 15 you have to choose any 10. Okay, so here having choice option. So the section A is compulsory, but then section B, so out of 15 question you have to write any 10. Okay, so this is the new system introduced in this NEET. So 86th question, which of the following molecule is non-polar in nature? Okay, I think so CH2O, HCHO, so this one is formaldehyde, SbCl2, NO2 and POCl3. So this is organic compound, all other things are inorganic compound, but among these 4 options you have to choose the non-polar compound. I think this SbCl5 is the non-polar compound. Okay, so polar molecules occur when there is an electronegativity difference between the double bonded atoms. But non-polar molecules occur when electrons are shared equal between atoms of a diatomic molecule or polar bonds in a larger molecule. Okay, so here this one is considered as the larger molecule, SbCl5. Okay, so this is 2, 3, 4. Here 5 plus 1, 6, 2, 3. So 3, 4, 5. So obviously, so this one is the correct answer according to this one. Okay, and this is SbCl5 is trigonal pi pyramidal. Due to its symmetry, it's non-polar. 87th question. So the correct option for the value of vapor pressure of a solution 45 degrees Celsius with benzene to octane in molar ratio 3:5. So the total is, you have to sum up these two things, you get 5. So at 45 degrees Celsius, vapor pressure of benzene is 280 mmHg and that of octane is 420 mmHg. Assume ideal gas. Okay, so here 168 mm of Hg and 336 mm of Hg, 350 mm of Hg and 160 mm of Hg is given. Okay, I think so this option 336 mm of Hg is the correct answer. We will discuss with the solution. Pt is equal to PA and XA plus PB into XB. So this and all we already studied in the solutions. Already one question is from this colligative properties. So this is also from solutions chapter grade 12. Okay, so this is 280 is given 280. So 3 out of 5. So you have to add 3 plus 2, 5. So 3 divided by 5 plus PB is given, that is 420. 420 into 2 by 5. So you have to cancel the things. Okay, so 280 into 3, that is 840. 2 into 420, that is 2. So in both the cases, the common denominator is present 5. So 840 plus 840, 0816. So divided by 5 and then 3 5s are 15, remainder 1 8, 3 5s are 15, remainder 3 30 and then 6 5s are 30. So that is 336 mm of Hg. And 88th question. So the product formed in the following chemical reaction. So here sodium boron tetrahydroborane. Okay, so sodium tetrahydroborane in the presence of ethyl alcohol. Here acetone is present. So here reduction occur that is addition of hydrogen. So obviously this ketone is converted into alcohol. Okay, so let's check the option. So here within ring, so there is no change in the ketone group, so the change in the OH group. So here the ketone group present in the ring gets converted into OH, so the C double bond O group is in this one. Okay, and then here in both the double bond O gets converted into OH. I think these two options are wrong. Only one double bond O group is converted into OH. Okay, I think that A, so this B option is correct. So the ring, the double bond O group present in the ring gets easily reduced to OH. So NaBH4 will reduce ketone into secondary alcohol. And then 89th question, for irreversible expansion of an ideal gas under isothermal condition. So the correct option, del U is not equal to 0, del S total is not equal to 0. And then this is del U. Del U means internal energy, change in the internal energy, and this is change in the entropy, I think. Okay, so del S total. I think the correct option is the second one, del U is equal to 0 and del S total is not equal to 0. So for isothermal process, del U is equal to 0, but irreversible process will have del S is greater than the 0. Okay, so greater than 0, it's not equal to 0. So the condition is given, no, so this is isothermal condition. So particularly the clue is given, irreversible expansion. So for irreversible expansion, the del is greater than 0, not equal to 0. Okay, so greater than means that is more 1, 2 like that. Okay. And then 90th question. So the molar conductivity, already we discussed one molar conductivity, again another one question. So that question is also acetic acid is, you find the molar conductivity. Here also you find the molar conductivity of acetic acid is given. From this molar conductivity you have to find the dissociation constant. Okay, so the molar conductivity of 0.007 m acetic acid is 20 S centimeter square per mole. What is the dissociation constant of acetic acid? So here some clues are given. Okay, so this is del H value is given. I think this is dissociation constant of acetate ion and hydrogen ion. So this is anion and this is cation. Okay, so these values are given. So you substitute the formula. Okay, so these are all the options. 2.50 into 10 to the power of 4, 1.75 into 10 to the power of minus 5, 2.50 into 10 to the power of minus 5, 1.75 into 10 to the power of 4. So this 1.75 is the correct answer, but in these two options, one is 10.5 and another one is 10.4, 10 to the power of minus 4 and one is 10 to the power of minus 5. I think so the second option is the correct one. So alpha is equal to lambda m divided by lambda naught m, that is lambda m value is given 20 and lambda naught m is equal to 350 plus 50. Here the values are given, no, so you have to substitute. And then 20 divided by 100, so you have to cancel the things, 1 2s are 2 and 20 2s are, so that only 1 by 20. And then Ka value is equal to C into alpha square. So alpha value is given here. So the C value is also given in the question, 0.007 into 1 divided by 20. So 1 into square, 1 square. So 1 again multiplied with this 0.71. So 7 into 10 to the power of minus 7. Okay, 1, 2, 3 minus 3. And 20 into square. So 20 into 20, 2 2s are 4, you have to put 00. Okay, and then you have to cancel the things. You get the answer 1.75 into 10 to the power of minus 5 mole per liter is the correct answer. And then again already we matched one question. So I think 2 or 3 questions are from this section C part. Match list 1 and list 2. So this is also important. So in 2018 paper, 19 paper, 20 paper, all papers contain one question from this one. Okay. So match list 1 and list 2. So this is spin. So magnetic moment. Okay. So spin only moment. Okay. And then this is n into root of n into n plus 1. Okay, here. So the first one A, the option is 4. So I will explain how to find this one. And B is equal to 1. And C is equal to 2. And D is equal to 4. Okay. So this is FeCN6. So this cyanide group is the strong ligand. Okay, so Fe3 plus minus 3D5. So this is in the ground state level. After attacking this CN6, so all are paired. So this is also paired and this is also paired. Only one lone pair of electron is present and 2 empty orbitals. So here n value, n is equal to number of lone pair electron. Okay, so these are all already paired, only one lone pair electron is present, so n is equal to 7, n into n plus 1 root 3. So root 4 is equal to root 2 into root 2, so you have to cancel root and then, so this is approximately equal to 1.73 Bohr magneton or approximately equal to 2. So in the option, only one option is in the range. Okay. And then second one FeH26. So this is weak ligand. So there is no pair up occur here. So here the number of lone pair of electron is 5. So 5, so you apply in the formula 5 into 5 plus 1 root. Okay, so root of 5 into 6. So here n into n plus 2. Okay, so here, so 7. So that is 35. So this is approximately equal to root of 36. Approximately equal to root of 6 into 6. You have to cancel the things. So your answer will be approximately equal to 6. That is 5.92 Bohr magnet. 9 is more than 5. So you have to add plus 1. So this will become 6. And another one Fe2 plus 3D6. So in the presence of strong ligand, okay, so this is all are paired, there is no lone pair of electron, n is equal to 0. So this magnetic moment is also equal to 0. So this compound is considered as diamagnetic. From this mu value, you have to easily find the magnetic property also. This is diamagnetic property. And then these two things are paramagnetic due to the presence of the lone pair of electron. So this is paramagnetic. And then previous one is also paramagnetic. And then this one again FeH2O6 2 plus, and here in the presence of weak ligand. So only one electrons are already paired, other 4 electrons are considered as lone pair of electron. Here n is equal to 4, mu is equal to root of 24. This is approximately equal to 25. So 5 into 5 you have to cancel. Your answer will be approximately equal to 5, 4.90. And then 9 is greater than that of the 5. So you have to add plus 1. So this is 5. And choose the correct answer from the options given below. You have to choose. I think this third option is the correct one. 92nd question. Choose the correct option for the total pressure in a mixture of 4 gram oxygen and 2 gram hydrogen confined in a total volume of 1 liter at 0 degree Celsius. So here R value is given in the question paper and T value is also given in Kelvin scale. And then you just substitute all those values in the formula, you can get the answer 25.12. Okay, so this is P is equal to nRT divided by V. N is equal to 4 by 32 plus 2 by 2. So your answer will be 9 by 8. So you calculate the N value. So you substitute in the place of N 9 by 8 and then this is 0.821 and into 273. Okay, so here volume is equal to 1. So divided by 1. Okay, and then you have to cancel the things and then you have to multiply or find the product of the numerator value. You get the answer this 25.18. So you have to solve, you get 25.18. A 93rd question. So this is from again organic chemistry. So consider the above reaction and identify the missing reagent, that is chemical. Here CH3, CH3, COO, Na and sodium salt of propionate and then NaOH plus. So you find out this missing chemical and then heat. And then you get hydrocarbon ethane and sodium carbonate. So these two things combine together and you get alkane as such. So this is red phosphorus, CaO and DiBaLH-B26. I think so this calcium oxide is the correct one. So that is the missing one. Yes. Okay. So this is the example for decarboxylation reaction using soda life. Either the removal of the CO2 or in the form of Na2CO3. Okay. So this is sodium carbonate. And then the slope of Arrhenius plot lnk V by S into 1 by T. So first order reaction. So this question is from chemical kinetics chapter. So in chemical kinetics we discussed the first order, second order, third order and zero order reaction also. This question is from first order reaction. So the value is given -5 into 103 Kelvin. So the value of EA of the reaction is, so you find the value of EA. So choose the correct option for your answer. So here also the R value is given 8.314. So your correct option is 41.5 kilojoule per mole. Okay. And this is, so here it's not 103 into 10 to the power of 3. Okay. So here some alignment mistake. So 10 to the power of 3. So in K is equal to LNA minus EA by RT. So you have to keep as such this EA by RT. Okay. So EA by R is equal to, so this is slope. So that value is given in the question itself. And then EA is equal to 10 into R value is given in the sum, no. So you have to multiply. So this R into this side. So this is in division. So R value is given. So EA is equal to 15 into, so here minus is present, here minus is present. You have to cancel the value and then you get 15 into 10 to the power of 3 into 8.314. So you have to multiply these things. You get 41.5 kilojoule per mole is the correct one. The 95th question. So the intermediate compound X in the following chemical reaction. Okay, here one, this is toluene, that is aromatic hydrocarbon, reacts with chromium chloride CrO2Cl2 in the presence of carbon disulfide. So this is the solvent here. So first you get one intermediate product, and then from that intermediate product you get. So this toluene is undergoes oxidation to form. So this is benzaldehyde. So in between one product is formed, so you have to pick that product, okay. And then CHOCOCH3 twice, that is anhydride. And then here 2 hydrogen is replaced by 2 chlorine, and only 1 hydrogen is replaced by 1 chlorine. And then CHOCROHCl2 2 times. I think this one is the correct one. So intermediate product, one product is formed, and then from this product itself you get CHO. So this is the intermediate product. And then this is Itod reaction. So this reaction name is Itod reaction. So this is Itod reaction. And this question is from hydrocarbons, grade 11. Hydrocarbons, grade 11. And then again match the following question. So we already discussed 2. Here SO2 plus O2 to give SO3. Okay, sulfur dioxide reacts with oxygen to form sulfur trioxide. And then HOCl, so reacts photochemical reaction in the presence of light to form smog. And then so this, yeah, so free radicals also, OH radical and chloride radical. And then calcium carbonate reacts with sulfuric acid to form ozone depletion, and NO2 in the presence of light. So this is also photochemical reaction. So to get NO gas and then O gas, that is tropospheric pollution, you have to match. Okay, so here A is the 4th. So this one is responsible for the tropospheric pollution, that is air pollution. And then second one is for, this one is responsible for ozone depletion. And then the CaCO3 and H2SO4. So this is carbonic acid, and this is responsible for acid rain. And 2 NO2 in the presence of light to form NO plus O. So this is responsible for smog. Okay, so the correct option is this one. And then this is 97th question. From the following pairs of ions, which one is not an isoelectronic pair? We discussed this one in atomic structure, grade 11. So this is the second chapter in grade 11. So this is also very easy one. So Na plus and Mg2 plus, Mn2 plus Fe2 plus, Fe2 plus and Mn2 plus. This is both are in cationic form having the same charge 2, O2 minus and F minus. I think Na plus 10, and this is also Mg2 plus 12 minus 2, that is again 10. Okay, so this is isoelectronic pair. And this is also Mn2 plus and Fe2 plus. And then here you consider this one O2 minus, so 8 plus 10, and F minus, so addition of 1 electron to this fluorine, again 10. Okay, so you delete these two things and then you have to choose these two things only. I think this third one is the correct option. Okay, Fe2 plus has 24 electrons, and Mn2 plus has 23 electrons. Okay, Fe2 plus. So here Fe2 plus, this is 20. So this is again, so this is also 23 and this is also 23. And here 23, 22. So this is the number of electrons differ here. So the correct option is this one. And 98 question, again you match the question. So in the class itself, most of the time I repeated this one. You have to give more importance to the naming reaction. Okay, here benzene reacts with concentrate, that is carbon monoxide and HCl in the presence of anhydrous aluminum chloride or copper chloride. Okay, so you have to name. And the next one, RC double bond OCH, that is ketone. So the first one is reaction chemical properties of the hydrocarbon, and second one is chemical properties of the ketone, and next one is chemical property, that is reaction between the alcohol and COOH. I think so this one is esterification, and then second one carboxylic acid chemical property. So you have to match. So this one second one. So this reaction is called as Gattermann-Couch reaction. And then second one, so A, second B is third one, haloform reaction. So this one is because the X is halogen, haloform reaction. And then third one is esterification. And fourth one is Hell-Volhard-Zenke reaction. Okay, so this one is correct. So the option, third option is correct. And then again, so this one, in which of the following arrangements in the given sequence is not strictly according to the properties indicated against it. So here also you pick not strictly according. Okay, so in which one of the following arrangements the given sequence is not strictly according to the properties indicated against it. So here some periodical properties, periodic properties are given. So you have to choose the irrelevant property. H2O, H2S, H2S E and H2TE. So this is hydrides of 16th group element, oxygen family, and then this is hydrides of 15th group, and this is 14th group, and this is 16th. So this is 16th group of P block elements, and this is 15th group, and this is 14th group, and this is 17th group. So this is also, this question is also from P block element. So both grade 11 and grade 12. So this increasing pKa values, I think this one is the incorrect statement, are not relevant, are according to the periodic property. So this is not a sequence. Okay. Yes, increasing pKa values. And this is the last question in chemistry paper. So the reagent R in the given sequence of chemical reaction is, so here, so this 2,4,6-tribromo, okay, so aminobenzene reacts with Na, NO2 and HCl. So here one hydrogen is replaced, okay, and then you get Cl, NCl, and then Br, and then here one reagent is missing. So you have to find that missing reagent. I think this is absolute alcohol, CH3, CH2, OH, ethyl alcohol, or otherwise absolute alcohol. The reagent missed here is absolute alcohol. So this is from Amine's chapter, and you study this one in haloalkanes also. So this is the interrelated one from Amine's, and as well as haloalkane and haloarine, haloalkane and haloarine. Okay, so this is, so you study this one in grade 12. So let's check with your answer. That is CH3, CH2O and then hydrogen iodide, CuCN in KCN, H2O. I think this option is the correct one, CH3, CH2OH. So, okay, so far we have discussed all 50 questions in 2021 UG NEET paper. I think the explanations are enough for your understanding. Hope you would all write the exam very well. Okay. So, thank you all for listening my session. Okay. Thank you all.